Hey guys, so I'm actually very excited to teach you this lesson today because it is the last one that you will ever have to do for this class. So let's go ahead and get into it and get it finished, and then you guys are done. Summer is on the way. So we are on part 5 today. We skipped part 4, so don't worry, you didn't miss it. We aren't doing part 4. So part 5, we are going into more of the Pythagorean theorem. So let's talk about what we need to recall and remember. So we're going to use the diagram at the right to prove the Pythagorean theorem. This proof will show that the area of the large square is equal to the sum of all of the areas of the small square and the 4 triangles. So the area of the large square is equal to the sum of the areas of the small square, this white square in the middle, and the 4 triangles. Okay? So let's start by finding the area of the large square. Okay? So to do this, our formula is area equals length times width. All right, so we're doing the large square, so AB on both sides. So A plus B times A plus B, length times width. So then you FOIL this out. A times A gives us A squared. A times B gives us AB. B times A gives us AB. And B times B gives us B squared. And then we can combine those like terms, so we get A squared plus 2AB plus B squared. Oh, that is not straight. All right, so that's the area of the large square. Then it says to find the area of the small square, which is the white. So each side is C. So once again, length times width, but it's just going to be C times C. So C times C gives us C squared. Okay, now it says there are 4 triangles. Find their total area. So we're not just trying to find the area of one triangle, but the area of all 4 of these triangles. So if the area of our triangle is 1/2 AB, but we have 4 triangles, it's going to be 4 times 1/2 AB. And anytime you multiply by a fraction, you are basically dividing. So what is 1/2 of 4? That is 2. So 2AB. Okay, so then this is where we prove it. The area of the large square equals the area of the small square plus the total area of triangles. So the area of our large square, this one up here, should equal the area of the small square, which is C squared, plus the total area of the triangle, so 2AB. All right, and then it says to solve for C squared. Okay, so the first thing we can do is get rid of this 2AB so that we're solving for C squared. So we're going to subtract 2AB from both sides. And notice we have positive 2AB on both sides, so those will just cancel out. So then we're left with A squared plus B squared equals C squared. And this is our Pythagorean theorem. All right, so now we're going to talk about finding the distance formula using the Pythagorean theorem. So we know that slope is our average rate of change. So this is rise over run, the change in y over the change in x, and y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is when you're given ordered pairs. Okay, so we're going to use the Pythagorean theorem to find a formula for the distance between points A and B. So you can see how we're going to use the Pythagorean theorem for this because this is essentially our hypotenuse, correct? So we've got C squared. All right, and so then we need to figure out A squared, okay? So A, notice we have y sub 1 and x sub 1, y sub 2 and x sub 2, okay? So we're going to say that our A squared is going to be our value for x. So x sub 2 minus x sub 1, not squared, x sub 2 minus x sub 1, plus b, which is going to be our y. Okay, so y sub 2 minus y sub 1. and then they're squared because that was what was originally in the formula. And it wants us to solve for c. So we have c squared, so the only thing we have to do is take the square root of both sides. So c equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And now, essentially, how we got this isn't really the most important part, but it's that you understand the distance formula, okay? So this is our distance formula. Notice it's the same thing that's down here. So given a graph, you can draw a right triangle and use the Pythagorean theorem, or you can use the distance formula, okay? So we can easily use, if we knew the value for these, we could find our hypotenuse using the Pythagorean theorem, or we can just plug it into the distance formula, which is what we just learned how to find. And this is what it always is. And then you'll plug in for the different values. Again, example 1 tells us to find the distance between the 2 points on the line using the Pythagorean theorem and the distance formula. So we're going to start off with the Pythagorean theorem. Now notice it gave us 0, -8, and 6, 0. Those are the 2 points that you see. And we can make a triangle out of this. Please don't judge my triangle. It's very hard to draw straight lines on here. Okay, but this is our triangle. Okay, so we know that the Pythagorean theorem is a squared plus b squared equals c squared. So then we're going to plug that in. So if our x value is 6, then we know that our value down here is 6. And the same thing, if we know that we've gone down 8, our value for this side is 8. And so we're trying to figure out what c is. So we're going to have 6 squared plus 8 squared equals c squared. So 6 squared plus 8 squared is going to give us 100 equals c squared. And then you want to solve for c, so you take the square root of both sides. So c equals 10. Okay, so our answers here should be the same. The Pythagorean theorem and the distance formula should give us the same number. Okay, so our distance formula, this is a new one, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And then we just plug that in. All right, so we need to figure out our ordered pairs, which is what we're going to use up here. All right, so this is our x sub 1, our y sub 1, our x sub 2, our y sub 2. So we're going to have 6 minus 0 squared plus 0 minus -8 squared. Okay, and you can plug this entire thing into your calculator, and once again, you'll get the square root of 100. So c equals 10. All right, looking at B, we've got our 2 points right here. I'm going to try my best to draw a straight line. Good enough. All right, so a squared plus b squared equals c squared. All right, so we know that our height, so we've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then our value for A, 1, 2, 3, 4, 5. So we're trying to figure out C. So we've got 5 squared plus 10 squared equals C squared. So 5 squared plus 10 squared gives us 125. All right, so notice that 125 is not a perfect square. So this is where what we just learned in the previous lessons comes into play. We want to factor this out where we can simplify it to the smallest value that we can make it, right? So we know that we can make 125 5 times 25, and 25 is a perfect square. So our square root of 5 is going to stay, but the square root of 25 is 5. So we get C equals 5 and then the square root of 5. All right, then we can do the same thing, but we can do it using our distance formula. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Right, and this is where we're going to use these points they gave us. So we have x sub 1, y sub 1, x sub 2, and y sub 2. Right, so we're going to have 6 minus 1 squared and negative 5 minus 5 squared. Once again, plug all of this into your calculator. We'll get the square root of 125 and do the same exact steps we had above. And we get the same answer. All right, the last thing that we're going to be talking about is the midpoint formula. So the midpoint of a line segment is the point M that is the same distance from each endpoint. So it's the center of the line, right? The point M is exactly halfway between the endpoints. Right, and this is your midpoint formula. M equals x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2. Okay, so this is going to give us an ordered pair, right? So this would be our x value, and this would be our y value. All right, so let's put that into action. So we have x sub 1 and y sub 1, x sub 2 and y sub 2. Right, so our first one, x sub 1, 0 plus 6 divided by 2. And then we're going to have negative 8 plus 0 over 2. And that's going to give us our ordered pair. So 0 plus 6 is 6. 6 divided by 2 is 3. Negative 8 plus 0 stays negative 8. Divided by 2 gives us negative 4. So your answer is 3, negative 4. That's your midpoint. Same thing for B. So we have x sub 1 and y sub 1, x sub 2 and y sub 2. So then we're going to have 2 plus negative 4. Be really careful with your signs that you're putting the negatives that go with the numbers included, but put them in parentheses, divided by 2. And then we're going to have negative 5 plus 3 divided by 2. So negative 2 plus negative 4 is going to be negative 2 minus 4. So 2 minus 4 gives us negative 2, divided by 2 gives us negative 1. Negative 5 plus 3 gives us 2. It would be negative 2, so negative 2 divided by 2, also negative 1. So these are your midpoints. All right, guys, that is it as far as lessons go. If you guys have any questions, as always, reach out to your teacher. And I hope you guys have a wonderful summer break.